Now that we're getting a hang of simplifying rational expressions, we're going to throw everything out at you. We're going to try to simplify 4x squared minus 25 over 15 minus 6x. This problem is going to introduce one other type of thing that we want to be careful of or to look for when we're simplifying rational expressions. And I'll make sure I note that when we get close to that component. So if you can with me, let's start to factor this guy down. Well, on top, I see a difference of two squares. 4x squared minus 25 is a difference of two squares, or that's its factorization. So I can factor it as 2x plus 5 times 2x minus 5. And the denominator is 15 minus 6x, and I'm looking, I think all I see is a 3. That might be common to both of those terms. So I'll factor out a 3, and I'm left with a 5 minus 2x. Well, at initial inspection, it doesn't look like anything cancels. I don't see any clever version of 1. But I kind of see lots of 5s and 2s and pluses and negatives, and I just wish they would line up. Well, what I know is that this 5 minus 2x and this 2x minus 5, both of the terms are opposite each other. This 5 is opposite of negative 5, and this negative 2x is opposite of 2x. So I can imply or look at a little tricky idea here where I'm going to factor out a negative 1 from this term. I know you're going, Willie, that's kind of crazy. Well, let's see what happens when it does so. So I'm going to keep this 2x plus 5, not going to do anything with that guy. I'm going to factor out a negative 1 from the second term. I know, hold on, I'll show you. As I factor out a negative 1, I'm left with a negative 2x and a positive 5. And you can double check that. I mean, all we do is multiply them back together to get to the original. So negative 1 times a negative 2x is a positive 2x. And a negative 1 times a positive 5 is a negative 5. And just for clarification, it's always good, I'm going to continue writing the entire problem down one step at a time. Alright, now I'm starting to get somewhere. I have both now a 5 minus a 2x and a negative 2x plus a 5. And those are actually the exact same thing. We remembered from a long time ago, our commutative property of addition allows us to switch these terms around addition signs. So what I'll do then is I'm going to rewrite this one. Start with the entire problem all over again. 2x plus a 5, negative 1, 5 minus a 2x, all over the denominator, which is a 3 over a 5 minus 2x. And now it's very apparent that I do have a common factor on both the numerator and the denominator, a clever version of 1. So I can go ahead and cancel those guys out, because essentially it's just a version of 1. And I have a 2x plus 5 times a negative 1 over a 3. And I'm going to try to clean that up a little bit and see what that looks like. So I'm just going to bring the negative 1 out, times the 2x plus a 5, all over a 3. And there's my final solution. You might see this written a couple different ways. I've seen some people to go ahead and maybe multiply that negative 1 in. So maybe their final answer will look like a negative 2x, negative 5 over a 3. That answer is also completely acceptable. When doing this problem, sometimes you're going to discover that there's a couple of tools that you have to pull from your tool belt. One, I had to factor a difference of two squares. I also have factored this, and throughout the factorization I started seeing that I think I had some opposite terms in there. Terms that differ just by a factor of negative 1. And if that's the case, just rip that negative 1 out and go from there.